Chapter 8, factoring is continued, and we're going to do special cases in type 2. That'll mean the difference of squares, perfect square trinomials, and type 2 factoring where the coefficient is bigger than 1. Right? Now, you must know some of these patterns, especially the perfect squares. They're very, very helpful for you to know. Perfect squares are a number times itself. You really need to know this. I can't stress that enough. It'll make your life so much easier. For example, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, and so on and so on and so on. So what you're doing is you're just simply going and taking whatever number and squaring it. Okay, so any number that you come up with is going to be a perfect square. Now, that also works with variables too. Anything with an even exponent is a perfect square. In other words, you could split it up evenly. When we're doing that factoring, if we had to take x to the 6th power and split that up between the two factors, it's easy to do. Each one would get 3. So those are perfect squares. So you can do those also. All right, let's erase all this. All right, so difference of squares. Difference means subtraction. And you must know that is important. It's not addition of squares, it's difference of squares. So it always has to be subtraction. 2 perfect squares would be numbers like this, or variables like this. All right, so for example, if we had a squared minus b squared, because that is a perfect square, and b squared is a perfect square, and we have subtraction in between, that will factor out really nice and makes a really quick factoring problem. It factors out to be a minus b times a plus b. And we multiplied these earlier, so if you remember that pattern, you'll see that it goes back to a binomial. If they have the same exact factors, except for one is positive and one is negative, then that will make a difference of squares. And if you distribute, what happens is the middle terms go away, or when you did the box method, the diagonal canceled each other out. All right, so note, with squares, this will only work if it's a difference. Addition will make non-real answers, and that in Algebra 1 for you will be considered prime. So in other words, if we had x squared plus 36, even though these are perfect squares, there's addition here. This would be, as far as you're concerned, prime. Okay, you'll learn about non-real answers and non-real solutions when you get to Algebra 2. But for now, if you have this situation, just know it is prime. All right, so let's do a couple problems. We have 25x squared minus 49. All right, is 25 a perfect square? Yes, it is. 5 times 5. Is x squared a perfect square? Yes. X times x. Is 49 a perfect square? Yes. 7 times 7. And is there a difference going on here? Yes. So then you can just split it up. And then easily do this. One's going to be positive, one's going to be negative, and then you pretty much take the square roots of these numbers. What's square root of 25? Well, that's 5 times 5. And how would you break up those x's? Well, we've been doing that all along. One here and one there. And then square root of 49 would be 7 and 7. So that made 5x plus 7. 5x minus 7. All right, let's do the next one. This is a perfect square, and this is a perfect square, and we have subtraction. So we take the square root of 16, which makes 4, and you split up your x's, and you take the square root of 81, which is 9 times 9. And it's one positive, one negative. And if you put the negative in front, that's okay. Does not matter. Alright, so that's finished. Alright, so now let's see if this is a perfect square. Is this perfect? Yes. Is this perfect? Yes. Is there subtraction? Yes. So you can go ahead and split it up. And you can take the square root of 4, which is 2 and 2, and x, one positive and one negative, and then square root of 9 is 3. And this y back here, split it up too. Now you have your final answer. Okay? All right. Now, perfect square trinomials, be very careful with these because they can be deceiving. Sometimes they look like perfect squares, but the middle doesn't work out. So you need to check them, make sure they work before you just write down the pattern. Don't confuse this with the difference of squares, which starts out with a binomial. This is not a difference of squares. This is a trinomial. We're going to see if it's perfect squares in the front and perfect squares in the back. All right, and must always have a positive in the back, or it's definitely not a perfect square trinomial. It may be factorable, but just not perfect squares. All right, let's see. So we have x squared plus 8x plus 16. Is x squared perfect? Yes. Is 16 perfect? Yes. All right, so then if you split that up, you notice that we have a plus in the back, which means it's always positive, or excuse me, always the same sign. And you look in the front, it's going to be plus plus. If you split up this, x, and you take the square root of 16. Now, we need to check this because if it does not make 8x in the middle, then it is not a perfect square trinomial. So you can take your box and you can do x plus 4, and multiply. X squared, 4x, 16. The middles make 4x plus 4x, which is 8x. So this is a perfect square trinomial, and that is its factored form. All right, so make sure that you check the middle. And remember, if it is a perfect square trinomial, that means that it can be written like this. So if you see something like this, or something like this, you know, it's the same exact thing. You could write it like this with the little square, or just know that these are the type things that will make perfect square trinomials. Okay? All right, so let's look at the last example. Let's just use this. Move this out of the way. All right, 4x squared minus 5x plus 25y squared. All right, so the front end's definitely perfect square, and so is the back. So let's see if we can do that. That would make square root of 4 is 2x. It's going to be minus minus because we have a plus, so it has to be minus minus. So let's put that. And then if we're following this pattern, square root of 5, square root of 25 is 5. Square root of y squared is y. And that would also be over here. Now, let's double check, okay? If you were to make a box, let's see if I can make a box over here where you can see it. And put 2x, 5y. It's a minus 5y. 2x minus 5y. All right, so multiplying 2 times 2 is 4, x times x is x squared. 2 times a negative 5 is negative 10xy. Same here, negative 10xy. Where did my y go up here? And then the last one would be negative 5 times negative 5, which is 25. And then y times y is y squared. Okay, look in the middle. That's a negative 10 and a negative 10. That makes a negative 20xy. What do we have to start with? Negative 5x. So this is not a perfect square. This is not a perfect square trinomial. All right, so you would have to go about this one a different way to factor it. But it will not follow this pattern because it did not work in the middle. So you need to watch these. All right, and finally, factoring type 2. You need to be very good at doing these because not everything is very simple like the type 1s. You always have to remember to GCF if you can. You must multiply the quadratic term, to the back end, the constant term. You'll be looking for numbers that multiply to give you that product, and then the sign rules, you'll still apply those. And when what you'll be doing is rewriting the middle, and then you're going to be grouping. So that's why we start with grouping, because we end up using it at the end. So let's show you what we're going to do. You're going to have a problem, and notice the coefficient of the quadratic term is bigger than 1. So it's 7x squared plus 16x plus 4. So you will multiply the front and the back, and you will get 7 times 4, which is 28. That add to be 16. Add 16. Okay? What multiplies to give you 28? So that's going to be 1 and 28, 2, 14, and 4 and 7. All right, which ones add to be 16? Well, that would be 2 and 14. Now, notice that we have same signs, and they're both going to be plus. So you would make sure that you have the middle rewritten. So you're going to write your first term. The first term here, you just write it down. Now, you're going to take these two terms that you found, and you're going to put them in the middle. And you're going to put an x with it. Whatever variable is going on here, you put an x with it. And then rewrite the last term. Okay? So all we did is, this is the same as what we started with, and this is the same as what we started with. We just rewrote the middle so that we could work it. So we had 16x, and now we have 2x and 14x. That's split up so you can now work with it. And now we do grouping, which we take the first two terms and the second two terms in GCF. So what is in common between 7x squared plus 2x? Well, the only thing that's in common is an x. So that comes out, and you're left with 7x plus 2. What's in common between 14x and 4? Well, the only thing that's in common is a positive 2, which leaves us 7x plus 2. So these are the same. We know we did it right. Then you put your leftovers together and one of your repeaters. And now you have factored a type 2. Okay? Just takes practice and knowing these rules. All right, so we will practice this in class. A lot of times, if you need help, come see me in the mornings or after schools, when I'm available. But yes, definitely come and work with me, and I'll sit with you and we'll go through problems one at a time. Keep practicing. See you in class.